and welcome again to the next session of this day. For this session, we have two speakers. We have Andreas Jansen, who is joining us from Germany. Hello, Andreas.
Hello.
And we have Tom Vanheertum, who is joining us from the Netherlands. Hi, Tom. Good afternoon.
Hi, everyone.
Hi. So today, Tom and Andreas are going to talk about circular flexible packaging. Everyone, we are waiting again for your questions in the Q&A chat on the right-hand side of your screen. With saying that, Andreas, Tom, the stage is yours. Enjoy the presentation.
Thank you, Daria. Welcome, everyone, to our sustainability conference. Today, we're going to talk to you a little bit more about the design of circular flexible packaging and the role of laminating adhesive in these packaging types. So let's first start to talk a little bit about why are we doing this. If you look at the total world production of plastics, and this is plastics including all kinds of plastics, ABS, polystyrene, PVC, garden furniture, whatever type of plastic you can think of is encompassed in this 400 million. If we look in Europe for flexible packaging alone, that means that there is about 4 million tons of flexible packaging being produced in Europe, out of which 1 million ton is not considered to be recyclable. Out of the 400 million tons at a worldwide scale, only 18% is really ending up in a recycling stream. So that means that only 18% of the 400 million tons is recovered on an annual basis. So you can imagine, after 60 years of plastic production, how big that mountain has become. And this is also why we see a lot of ocean plastic floating around. If we continue as we are doing today with the growth rate of recycling in the world, we expect to only be at 46% of recycling rate by 2050. So that means that if we are aiming for this carbon neutral type of target that everybody's thinking of, we won't get there. Certainly not if we know that by the late 80% of the recycling rate, things get only more difficult. So that means that we really need to pick up the pace and start thinking about how to do things differently and how to really change design of packaging to make sure that everything can be collected, sorted, and recycled later on. Looking at a bit of these drivers in the industry, looking at flexible packaging specifically, of course, consumers are being more aware of what is going on in the world, and consumers are actually also pushing themselves to get rid of plastic, to try to reuse a lot of the plastic they get into their homes. And hopefully they also are looking at recyclability logos on their packaging. So this is really driving consumer demand, and we see that end users, brand owners, but also pack designers, converting lines are trying to adapt to the trends that we see with consumers. Obviously, these consumers are being trained by NGOs. They're made aware about what is going on with the world, and they obviously also feel the consequences. So it looks like there is a certain drive in the market that is really looking for more sustainable packaging. So if we look at these other drivers, there is the circular economy. A lot of these initiatives can be industry initiatives or can be NGO type initiatives, other type of consortia like CFlex, for example, which is an industry corporation trying to change the design of packaging so that it can be recycled. On the other side, there is obviously a legislative push. So governments are really interfering there with taxes, with other initiatives that make it impossible to put certain products on the market. So that obviously needs to be taken into account. On the other side, we have to look at raw materials. So if you look at the impact of the current crisis and material availability, it has been rather poor in the last couple of years, let's say. But also there, if we look at what are we using, we're using bio-based raw materials, which don't necessarily mean that packaging is recyclable. On the other hand, there is recycled waste streams. So where can we use these? Can we use these in the same use case as they were used before, or can you only downcycle these materials? So those are very important questions we try to answer while trying to address this problem. if we dig a little bit deeper into the value chain, we can actually see that indeed circularity, there is a reason everything should be reused in the same type of application, because otherwise, indeed, like I said, you end up with a downcycling type of activity. So when new products are being produced, they are being packed and they're shipped to retail stores. A lot of what I'm going to discuss here is in the middle, you see the EPR, which is Extended Producer Responsibility. These organizations basically ensure initiatives between groups which are not normally connected directly to each other. So they try to figure out a way to provide incentives in the industry that people take action so that other players in the industry can follow up with those actions and you actually close the circular loop. So that means that with EPR, you get this eco-modulation where you're trying to make products better. If they are not better, they get a higher tax on them. So that means that this should drive a better packaging design, which is then collected. Again, collection is driven again by all kinds of incentives to make sure that this happens. Sorting, again, a lot of investment needed if you really want to sort every type of plastic, but also alu and paper out of a waste stream. And that then determines the quality of the waste stream, whether or not it can be mechanically recycled or chemically recycled. So Andreas will talk a little bit more about how we propose to do this by using our technology.
Yeah, thanks, Tom. I hope you can hear me. So, yeah, Tom described it already. So, when we talk about how to enable circular economy, of course, we have to consider that we have to keep the flexpack requirements as they are, showing on this slide that we have, of course, to protect our goods, our filled content against moisture, against oxygen, against environmental influences. So that's, of course, a key function of the packaging. And at the moment, this packaging is done with multi-substrate layers, so meaning different types of plastics combined to each other to give certain properties like mechanical resistance, for example, or even the barrier properties. So, and actually, what you can see here on the slide is showing some examples of this kind of multi-substrate material, which is really difficult to recycle, because partly you cannot at least debond those materials in the recycling stream. So it makes very difficult to have a pure plastic afterwards, a pure type of plastic afterwards. So what can we do? What can we do to enable a circular economy? We have to change the packaging design. We have to go to monomaterial packaging, as we shown here on the right hand side with this example. And actually, what we have also to do is to rethink about our packaging design in terms of barrier layers and barrier properties. The allnex answer to enable monomaterial packaging design is at least polyurethane dispersions. I will shorten this up in this presentation as PUD. The PUDs can replace the existing barrier coatings, what we have in the multi-substrate packaging, for example, EVOH, which is quite common in use in packaging and FlexPack in particular, providing a very good oxygen barrier. But actually, this one has not good moisture barrier properties. When moisture comes in place, then EVOH gets a problem. So that's why it needs an additional tile layers to be have a kind of sandwich in between the packaging. The second example here is showing the aluminum or PVDC barrier coating or barrier layer. Actually, those are claimed as being not recyclable at all. So what is the answer of allnex? As I said it already, it's the PUD. So because PUD comes with already some barrier properties against oxygen and moisture, and you can combine this also with Ciox or Alox layers to even improve this barrier property. Tom, next slide, please. So, talking about dispersions, actually, I want to highlight some features of those PU dispersions, why we think this is the right way to go to enable monomaterial packaging design. So first of all, you have a very good adhesion to multi-substrates, including plastics in every color you can imagine. The PUD forms a very flexible, crack-free, and as well as residue film after drying. It provides a very good mechanical and scratch resistance, and our PUDs are especially VOC free. This belongs to our special production process where we produce our PUDs without any additional co-solvents. Now, and to add this here as well, so we have also some bio-based material under development now. So Tom, next slide, please. Thanks. So highlighting also some benefits why when you use a PU dispersion. Besides the barrier functionality, what I mentioned already, you have a structure simplification of your packaging. You saw it already on the slides before. So meaning when you have less material to recycle, it makes it, of course, easier to recycle. So you have no issues with flex crack resistance, with packaging strength and integrity. PUDs are very good in the sterilization process, so you can use it for food packaging as well. It has, you can, partly replace PET with those. They have no migration or low migration because the PUD film, when it's cured, it's totally cured. That means there are no residues left what can migrate. So meaning you don't have to worry also about substance of high concern as well. So Tom, next slide, please. So this is a short overview about our PUD portfolio. Actually, there are not all of our PUDs listed here because there are more than 50 in place for in different applications, different markets. Let me highlight 3 of those of our portfolio. So the DAOTAN 6450, the DAOTAN 7000, and the DAOTAN 7010. All of them have a very good multi-substrate adhesion, particular to plastics. The DAOTAN 6450 is a very good moisture barrier. It's used in lamination adhesive applications. The DAOTAN 7000 is very good compatible to inkjet printing, also a big trend in FlexPack nowadays with inkjet printing, and is also very good water resistant. And the DAOTAN 7010 actually provides very good oxygen barrier properties, and additionally when you use PVC in your packaging is also very good plasticizer barrier to prevent plasticizer to migrate into the packed content. Maybe let me add to this slide. So of course we have a broad portfolio of PUDs, but what we also do, we are our sites very flexible, and we can also adapt our products to your certain needs. So don't hesitate to contact us if you have a certain FlexPack project and you think maybe a PUD is the right way to go. Just get in contact with us, and then we can talk about either there's a commercial grade available, or maybe we can, with an easily adoption, create a product which particularly fits to your needs. So, and last but not least, let me mention also here that DAOTAN 6450 as well as the DAOTAN 7000 are also part of our EcoWise portfolio, what my colleague Tejaswini already told you in the sustainable portfolio management presentation. Yeah, thanks a lot. So if you have any questions, let us know.
Yes, I will let you know. We do have questions, and everyone, let's go to it's question time. Let's go to your questions. So the first question, does PUD way mean isocyanates? Do you think that isocyanates will be regulated in the future?
Yeah, maybe I can pick this one up. Okay. In the end, PUDs, you have the difference between OH functional PUDs, which can be used as a 2K system, and you have PUDs, which are used as a 1K product. 1K product means that the product is fully formulated. There has been a chemical reaction between the isocyanate and the OH functionality, so you end up with a urethane bond. So that means that there is no free isocyanate in the system.
Thank you, Tom, for taking this question. The next one, do you see the use of your polyurethane dispersions as particularly sustainable?
Yeah, maybe I pick this one, Tom. So actually, yes, we do, because as I already mentioned, yeah, first of all, PUDs with their technical properties enable monomaterial packaging design, which is actually needed to create a circular economy and to have the material or the packaging easier to recycle. It's applied in very, very thin layers, so it's below the 5% of adhesives and inks mentioned in the CFlex guidelines for circular packaging. Yeah, it contains no VOCs, which is of course very, very environmental friendly. And as I mentioned before, we have also bio-based versions now under development as well.
Thank you, Andreas, for taking that one. The next question, are the PU dispersions also usable for on-paper materials to create a moisture barrier or do not negatively influence the paper recycling? Is that the case?
Maybe I pick up this one as well. Actually, we have some projects and some customers who are using PUDs on paper. So the feedback we have so far is no, there is no influence on the paper recycling. Actually, again, the layer we talk about maybe 5 to 8 micron dry film thickness, depending on the product you create. So the percentage of the PUD is so very low that it makes no big impact on the paper recycling at all. So, and what was the second part, Daria, of the question?
You covered it all, Andreas.
Okay,
Thank you
perfect.
so
Okay.
much. The next question, have you already checked the influence of your PUs to the mechanical recycling? The person who asked that thinks that low molecular weight PUs of the PUs could be a problem. Shall I repeat
Yeah.
the question?
Yeah.
Yeah, no, we got the question. To be honest, we haven't really investigated this, so we haven't gone through a formal check of looking at the recyclability. I mean, it could also always happen that certain residuals are there, but to our knowledge, I mean, our PUD should not yield too many low molecular weight fractions, which could be of concern. But again, reusing that in food packaging obviously has to be determined and will be obviously also related to the quantity you will be using.
Thank you, Tom, for answering this one. And we have 5 votes for the next questions. Are your products the isocyanate free?
The use of PUDs, if you want to make PUDs, obviously you're going to be using isocyanates in the production, but you don't need to use isocyanates specifically to make use of our products. So again, there is no free isocyanate in the formulation if you don't want to.
Understood. Thank you so much. In the example, the next question, in the example you presented, you compared a system containing an EVOH barrier with one of that layers that has PUD. How would this perform in terms of cost performance balance?
Yeah, actually, of course, the PUD is a little bit more expensive than EVOH, but EVOH is mainly used in multi-substrate packaging. So that means Tom presented already also regarding the EPR schemes we're talking about, and we see it a lot in different countries already that you have to pay additional fees for participating in those schemes. And when you have material which is non-recyclable, the costs are higher for that. So what we think is when you think about using a PUD in your packaging design and also with the structure simplification you have, so meaning less layers, these costs will be equalized in midterm.
Thank you very much, Andreas. The next one, is it correct that many PUDs still contain solvents?
Yeah, I can take that question, or Andreas,
Okay.
if you'd rather.
Actually,
Okay.
Yeah, please do so, Tom.
Okay. No, I think, yes, in general. So in the market, you can find PUDs which still contain solvent. There is obviously a process to produce PUDs in a solvent-borne process and then later on extracting that solvent. But as Andreas already explained, our process of the grades we listed there is completely solvent-free. So that means that there is no solvent in the product as supplied. and you also don't need to add additional solvent to get proper film formation at ambient temperatures.
Andreas, would you like to add something
No,
or?
actually, I just want to say nothing to add here because it's actually it would be exactly my answer as well.
Wonderful. The next question, does the PUD act as a moisture barrier on paper?
I mean, this is a little bit related also to the other question what we had before.
Correct.
Yeah. So yes, it does. Yeah, but it depends, of course, which PUD you're choosing. As I explained before, we have a broad portfolio, and what we do is, of course, checking together with the customer if the product fits to the application. So we have also application lab capabilities. Now we have a quite new R&D center in Austria and Werndorf, where we have a very nice application lab where we can check this, and make it fittable to your application, your product.
Thank you. The next one, what are the advantages and limitations of waterborne PUD resin in flexible packaging?
Andreas?
Yeah. Okay. Yeah. I mean, what the advantages? Advantages. I mean, we highlighted it before. Yeah. You don't have any solvents in the process, so no need to concern about volatile content, which is of course a big topic, especially in the packaging industry. No substance of high concern. This is a big advantage. Disadvantage might be that you have, of course, to adapt your production line. Yeah, you have to make a slightly investments. So depending, so a water-based system has to be treated a little bit differently in application. And when you think about exhausting, for example, about the drying portfolio you need to have, these kind of things might create some additional costs, but not necessarily. It depends always on the type of customer and the production line the customer has. Yeah, but on the other hand, I don't see big disadvantages to use a water-based system in packaging.
Thank you, Andreas. The next question. Can our PU product line, can it be easily vacuum metallized?
Actually, what we know is that PUD is very good for vacuum sealing. So, and vacuum metallization, actually, this is something we have to try out, to be honest. Yeah, because in the projects we had so far, this is was not now our big focus now at the moment. But on the other hand, what we know is that you really can combine with Sioxar layers. So that should work actually. But I would try it out. So reach out to us and we will check in the application lab, as I mentioned before, and we will figure it out.
Thank you again. And the next one, can the PUD packaging be printed with multiple colors and simultaneously?
Yeah, that shouldn't be a problem at all. Yeah. Also, we have some applications where we use the PUD as a ink receptive primer, for example. Yeah, for inkjet as well as for flexographic printing. So, and there was no big problem or no problem to print with different colors on it. Yeah.
Thank you, Andreas. And the next one, uh, uh, could you elaborate on which applications the mentioned DAOTAN grades have been used in?
Yeah, the DAOTAN 7000 is quite common use as a oxygen barrier coating on paper, and the question were already there. Yeah, if we have some PUDs which are fittable for paper, as well as on aluminum oxide. The 6450, what I mentioned before, is used as lamination adhesive, particularly in multi-substrate packaging, and of course also suitable for mono material packaging. And this gives very good moisture and oxygen barrier in particular. And the DAOTAN 7000, the last one, is in testing now for thermoheat-sealable packaging, as well as for high transparent packaging, because it provides a very nice transparency when it's dried out.
Thank you very much for that. And we go to the next. Can the TW7010 be used on PE films? What level of oxygen barrier can you achieve with this product?
Tom, you want to take this one?
Yeah, sure. I mean, I think yes, these PUDs provide fairly good adhesion to polyolefins. I mean, even also there we try to look at non-corroda treated films. So these PUDs stick to those fairly good. Yeah, we have to say if you look at oxygen barrier, obviously why we propose Ciox Alox treated films is the reason that you can't get a perfect high barrier property, but getting to a level which is very close to a PET film, we believe is possible. So that means that just replacing PE-PET laminates, this should be in the realm of possibilities with a sandwich of PE, PUD, and another layer of PE.
Thank you for answering this one. And we move to the next. We still have a couple of minutes. What is the most important property of PUD for use in flexible packaging?
Yeah, maybe I take this one. So it's a at least there are a bunch of. Well, I said it on already when I showed the features. So for me, the most important thing is the very high flexibility, the very good adhesion. So meaning, as I mentioned before already, so you don't need additional tie layers to bond on different types of plastics. The high flexibility and the crack-free film formation, which is also very important. You can imagine when you you bunch a flex pack and the film cracks, then you don't have any barrier properties anymore. So this is also an outstanding, very nice feature of a PUD as well.
Thank you, Andreas, for answering this. And the next one, are all the PUDs compliant for indirect food contact, or maybe some of them even for direct food contact?
Yeah, actually, all of them so far, what you've seen on the slide, are compliant to non-direct food contact, I have to say. Actually, we're working also on direct food contact. Yeah, so we have in our application lab we have some developments running where we think that is the right way to go for direct food contact. Actually, one PUD grade, the 6490, I didn't highlight it here, but this is is mentioned as direct food compatible. But actually, this has to be proven if it fits to FlexPack. That's why I didn't mention it before.
Thank you. And the next question, aren't 100% UV resins the best environmental choice for flexible packaging or not? Can you please comment on that?
Yeah, I think that was the topic of our previous presentation, right? So I guess, yes, I mean, we do see that there are some concerns regarding UV, and as allnex, we don't exclude any option. So obviously you can look at both. We are not here to say that one choice is better than the other. Obviously 100% UV is applied in a completely different process than a waterborne system that cures by forced cure or just ambient cure. So also there you have to make a choice depending on what is the line you have at your disposal or your customer has at your disposal, and what is the system that actually fits to that line requirement if you want to get certain properties at the end of the day.
Thank you very much. And that was the last question for this session. Thank you again, Tom. Thank you, Andreas, for presenting, for answering the question. And everyone, thank you for asking these questions. If you would like to get in touch with our experts, with Tom and Andreas after this session, you can do that using this platform. You can send them a message, emailing them, or invite them for a meeting. With saying that, I would like to conclude this session, and I will be waiting for every one of you in the next. See you in 10 minutes. Bye. Thank you again.
Bye.
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 Thanks
Thank you very
for
much.